All right. So students, how many of you already know the Pythagoras theorem? Raise your hand. Anyone? Very good. Now, let's do a quick revision. Whenever you see a right angled triangle, so the two shorter sides, let's call them A and B, and let's call the longest side C. Now, take note that the longest side is always going to be C. And the longest side is called the hypotenuse. Hypotenuse, okay? Now, what's the relationship between these three sides? A squared plus B squared equals to C squared. That means the sum of the square of the two shorter sides will be equal to the square of the longest side. One of the most common examples is One of the most common examples is 3 to the power of 2, 3 squared plus 4 squared equals to 5 squared. Because when you add them together, 3 to the power of 2 is 9, 4 to the power of 2 is 16, and guess what? 5 to the power of 2 is 25. 9 plus 16 is 25. Okay, so it works. 3 squared plus 4 squared equals to 5 squared. And there are many common examples that works as well. Look at all this. These are all Pythagorean triples. So we call them Pythagorean triples. And if you memorize them, your workings, you'll solve the questions faster because you recognize the numbers and you don't need to do so many calculation. So one of the top three most commonly tested Pythagorean triples are these three here. Okay, so if you can memorize these three, it'll be very good. 3, 4, 5, 6, 8, 10, 5, 12, 13. So if you can memorize these three, then you'll find your life much easier when you solve Pythagoras type of questions. Okay? 3, 4, 5, 6, 8, 10, 5, 12, 13. Let's just give one example. Okay, for example, if you have a right angle triangle, you must always start with a right angle triangle. Pythagoras theorem only works with right angled triangles, okay? So let's say you have a right angle triangle and I tell you that the length of this side is 5 and the length of this side is 13. Then I ask you, what is this length? Immediately, if you remember your Pythagorean triples, then you'll remember this 5, 12, and 13. So you'll immediately be able to tell me that this side is 12. Okay? So that's how it works. If you remember your Pythagorean triples. Now, students, there's another rule that we can learn here. And we call this the 30 degree rule. Why? Because when you see a right angle triangle and you see an angle 30 degrees, then all you need to do is look at the opposite side. Okay, there's a side that is opposite to this 30 degrees. And it is going to be half the hypotenuse. Now remember what I said. The hypotenuse is the longest side. That is called the hypotenuse. And by the way, hypotenuse only exists in right-angled triangles. Right-angled triangles, okay? Not just any triangle, right-angled triangles. So the hypotenuse is the longest side. If you see 30 degrees, all you need to do is look at the side which is opposite the 30 degrees. It will be half the length of the hypotenuse. So let's do an example. If I were to draw a right-angled triangle, and you see that this is 30 degrees, and I were to tell you that the length of the hypotenuse is 10, then immediately you just look at the opposite side, and you know that this must be 5 centimeters. Okay, students? So this is the 30-degree rule. So we are learning two things here on this page, the 30-degree rule and also a squared plus b squared equals to c squared. This is called the Pythagoras theorem. So whenever you identify a right angled triangle in the diagram, then you can ask yourself, can you apply Pythagoras theorem? Or maybe if you see a 30-degree angle, you can also apply the 30-degree rule, okay? And of course, it will be very helpful if you can memorize the top three Pythagorean triples: 3, 4, 5, 6, 8, 10, 5, 12, 13. So far, anyone have any questions? Raise your hand. Okay, are we ready to start trying some examples? Let's start with the very first example, okay? Okay, students, they say that the length of A is 8. The length of C is 17. And they're asking you, what is the length of B? Come, everybody, look at your Pythagorean triples. And can you just find the one that matches? Then you can tell me what is the length of B. Everyone type your answer in the chat now. Look at your Pythagorean triples and type your answers in the chat. Very good, Riven, Kyler, Elisha, you got it. Yes, Leandra, Reina, well done. Look at your Pythagorean triples. Which one can match? 8 and 17. So what is it? The third number. Yes, Nathaniel and Zheyu, well done. So students, look. If you take a look at the Pythagorean triples, you notice that there is 8, 15, and 17. So if this is 8, this is 17, the hypotenuse is 17, then the side B should have a length of 15. There you go. Very good, Jason. You also got it correct. Okay, so that's how useful the Pythagorean triples are. I'm not saying that you need to memorize all of them, but it will be very helpful if you can just memorize the top three. 3, 4, 5, 6, 8, 10, 5, 12, 13. Okay? All right, let's take a look at example number 2. So in example number 2, you have 3 squares and they connect it to each other, forming a right angle triangle in the middle. Now, what information do you have? They say that angle ABC is 90 degrees, which is the most important thing you need to look out for in order to apply the Pythagoras theorem. It only works if the angle is 90 degrees, okay? Then there are 3 squares. The length of AC and BC are 13 and 12 respectively. 13 and 12. Students, I think you can solve this. If you know your Pythagorean triples, you can immediately type in the chat right now, what is the area of square P? Come, type in the chat right now. What is your answer? Tell me the area of square P. Wow, so many of you are typing your answer. Very good. Leandra, Zheyu, Nathaniel. Who else? Oh, Reina. Yes, you got it, Reina. Very good. Jing Shen also. Yes, Elisha. Very good, Riven. Well done, Kyler. You're correct. So students, if you go back to your Pythagorean triples, I told you to memorize 3, 4, 5, 6, 8, 10, 5, 12, 13, correct? Do you notice that this is 5, 12, 13? So you immediately found that the side of the triangle, the side of the square is 5. So 5 times 5 is 25. Too easy. This is too easy. Okay? Anyone have any questions? All right. So let's try example number 3. Now, let's read the question and label the diagram. Whatever information they give you, we should write it down so that it's easier for us to visualize, okay? So let's see. AB is perpendicular to BC. There you go. AB is perpendicular to BC. AD is perpendicular to AC. Oh, they say that there's a 90-degree angle here. This definitely does not look like a 90-degree angle, right, students? It definitely doesn't look like it, but as you know, in mathematics, diagrams are not drawn to scale. So we just need to follow what the question gives us. Now, what else did they tell us? AD is 12. And what else? AB is 3. And AC is 5. AC is 5. Students, can you tell me, type in the chat, what is the length of BC using your Pythagorean triple? What is the length of BC? Yes, correct. Leandra, Jingshen, Riven, you got it. Anyone else? Yes, Zheyi, you got it. Remember your Pythagorean triples. Kyler, that's correct. Well done. What is the length of BC, students? Yes, Anika, correct. So you remember your Pythagorean triples. 3, 4, 5. That means 3 squared plus 4 squared equals to 5 squared, right? So we can say that the length of BC is 4. Easy. 3, 4, 5. Ah, Reina, very good. You got it as well. So we know that this is 4, right? And what else can we say? Do you notice that there's another right angle triangle here? And they said, and they already gave you 5 and 12. So what is this? Students, can you type in the chat, what is the remaining length? Yeah, very good. 13. Yes, 13. Correct, students. 5 squared plus 12 squared equals to 13 squared. Now, anyway, I don't think you need to find 13. It's not important it's not important because they're asking you to find the area. Okay, so they're asking you to find the area of ABCD, which means to say that you need to find the area of triangle P. Okay, I'm just going to call it P and Q. So if you find the area of triangle P and you find the area of triangle Q, you should be able to find the area of the entire quadrilateral. So actually, 13 is not really important because you only need the base and the height, right? Okay, students, I tell you what, I give you 1 minute. Why not you just calculate what is the area of the entire quadrilateral and type your answer in the chat. Come, everybody, type your answer now. Yes, Breven, very good. Yes, Leandra, Jingshen, you got it. Elisha got it as well. Who else? Yes, Jason got it. Nathaniel, Kyler, Anika, well done, students. All you need to do is make use of the area of a triangle, half times base times height. Right? Uh-oh, Zhe, you made a careless mistake, is it? Reina, you got it. So let's look at the triangles. Triangle P. Half times the base times the height. The base and the height must be 90 degrees to each other. The base and the height of a triangle is perpendicular to each other, right? So you look for the 90 degrees. This is the base, this is the height. Or you can say that this is the base, this is the height. Up to you. So it is half times 5 times 12. And we will get 30. And what is the area of triangle Q? Again, look out for the 90-degree angle. Half times the base times the height. And that will give us 6. So if you add them together, the area of the entire diagram, ABCD, quadrilateral ABCD, equals to 30 plus 6. And we have 36. There you go, students. Straightforward, right? Anyone have any questions about this? All right, so far so good. Let's take a look at example number 4. So, the length of one side, okay, come, let's draw a triangle. The length of one side of a triangle is 2 centimeters. The other two sides are 1 and square root 3. Okay, now can I ask Zheyu? Hello, Zheyu.
Hi.
Okay, Pythagoras theorem only works in what kind of triangle?
Right angle.
A right-angled triangle, correct. Now, what is the formula for Pythagoras theorem?
Uh,
A squared plus,
B squared equals C squared.
correct. Now, if we know that Pythagoras theorem only works for right-angled triangles, then if I have a triangle that can satisfy this equation, if it satisfies this equation, then do you think it's gonna be a right angle?
Uh, yes.
Yes, correct. Okay, so students, Pythagoras theorem works on right-angled triangles. If it is not right angle, then Pythagoras will not work. So if the three sides of a triangle satisfies this equation, then we can say that it is a right-angled triangle. So let's see whether this is a right-angled triangle, okay? 1 to the power of 2 plus, okay, what is the next one?
Square root 3 to the power of 2.
Yes, square root 3 to the power of 2 equals to?
2 to the power of 2.
Okay, 1 square is 1. What is square root 3 to the power of 2?
Uh, 3.
Yes, correct. Okay, students, square root is the opposite of square. So whenever you combine them together, they cancel each other out. Okay, so square root 3 to the power of 2 is just 3. Then equals to 2 to the power of 2 is?
4.
So is this a right angle triangle?
Yes.
Yeah, so straight away we say, okay, this is a right angle triangle. So now can we find the area? Come, let's find the area. The height, the base must be perpendicular to the height. So what's the area? Half times?
Base times 5.
Yeah, tell me what's the base?
Um, 3.
Square root 3 times
1.
1. There you go. What's the answer? Now give me an answer as a fraction.
Uh,
Just give me a fraction, the fraction answer, Zhe. What's half times square root 3?
uh,
Okay, never mind. What's half times? What is half times 5?
2.5.
Give me fraction.
5 over
Improper.
3.
5 over 2. Okay, come, tell me the answer now for square root 3. Half times square root 3.
Over 2.
Yes, square root 3 over 2. There you go. Well done. Thank you, Zhe. Any questions about this now?
No.
Well done. Okay, so students, anyone have any questions? Okay, what did we learn here? Since we know that Pythagoras only works for right-angled triangles, if the three sides satisfy the equation, then you can say that this is a right-angled triangle. And it is important to know. It's important to show that this is right-angled. Because if you don't show that this is right-angled, you cannot find the area. Why can't you find the area? Because you know that the base must be perpendicular to the height. So if you cannot prove that it is right angle, then you cannot have the base and you cannot have the height. Okay, so that's why it is important to prove that it is a right angle first. Then you can find the area. All right, let's look at example number 5. Okay, we are going to deal with a little bit of circles. Let's do a very quick revision on circles. This is a circle. This is the center of a circle. If I were to draw a line from the center touching the circumference, then we are going to call this R, which is the radius of the circle. Okay, students? So this is some basic knowledge about circles. And does anybody know what a tangent is? What is a tangent, students? Breven, you know, is it? Yes, Breven.
Um, a line that only touches a circle at one point.
Thank you, Breven. Well done. Students, look. Okay, if I were to draw a line, and this line only touches the circle at one point. So it barely touches. It barely touches. Okay, so it only touches the circle at one point, just one point. Then you can call this a tangent. And what's so special about tangent, students? If I were to draw my radius and I were to connect it to this point, guess what? You will get 90 degrees. That is what is so special about tangent. Okay, students? So, given this basic information, why not I give you 2 minutes? Let's see if anyone can find the area of the shaded region. Type your answer in the chat. Your time starts now. Okay, so Kyla, come. Let's take a look at the question. First, we are going to take a look at the smaller semicircle. Do you agree that imagine that, just imagine that the semicircle is part of this circle. So can I say that this is the center of the circle?
Yeah.
Definitely, okay? So let's just say that this is the center of the circle. So if I were to draw a line from the center of the circle touching the circumference, what do you call this line?
Radius.
Correct, radius. So let's call it R. Since it is the small semicircle, I'm going to call it small r, okay? Now, let's look at the big semicircle. Does it have the same center?
Oh, yes.
Yes, definitely. Okay, so if I were to draw a line from the center of the big semicircle touching the circumference, then can I also say that this is the radius?
Yeah.
Yes. Wait. There you go. And what did let's call it big R because it's the big semicircle, okay? Now, what did I say? Can you identify which one is the tangent? Which line is a tangent? Look at this diagram. Which line is a tangent?
Uh,
What is a
I need like the small
what is a tangent?
the line where they meet the circle.
The line that touches the circle at only one point. A straight line that touches a circle that only at only one point. So this line is a tangent, yes or no?
Yeah.
So can you look at this diagram and tell me which line is a tangent?
AB.
Yes, because AB touches the small semicircle only at one point. Yes or no?
Yeah.
So what is the angle there? Tell me, what is the angle?
90 degrees.
There you go, 90 degrees. So we have found our right angle triangle. And did they tell you the length of AB? What is the length of AB?
Hmm.
What is the length of AB?
7 cm.
Good. So can you tell me what is the length? So can you tell me what is the length here?
3.5.
Correct. 7 out of 2. So we can now use Pythagoras theorem. So tell me, what is the formula for Pythagoras theorem?
Uh,
A square plus
B square.
equals
C square.
correct. So can you tell me what is A? If you look at that right angle triangle in the diagram, what is A? Small r or big R? Small r or big R?
Small.
Correct. Small r, okay? Small r. What is C? C
Big
is
R.
you remember that word or not?
Hypotenuse.
Yeah. What does the meaning of hypotenuse?
Longest side.
The longest side, correct. So that means which one is the hypotenuse? If you look at this diagram, which one is the hypotenuse? Look at the right angle triangle. Which one is the hypotenuse? The longest side, which one?
R. Big
Which
R.
R? Big R, correct. Big R, correct. Okay, good. So now we're going to say a squared plus, what is b squared? What is b?
7/2 triple.
Yes, 7 over 2 equals to, what is c?
Big R.
Correct. Well done. So now my next question to you is, what is 5 plus 2?
7.
So easy, right? Why am I asking you such a random, easy question? Because I want to ask you, what happens if you take the number 2 and you bring it to the other side? Can I write it like
That's
that?
a minus. No, can't.
Oh no, this is wrong. So you must change a plus into a minus, right?
Yeah.
Yeah. So whenever you bring something to the other side, positive will become negative. Negative will also become positive. So what if I want to bring this to the other side? Then what will happen? What will you get? Because this
You
is
will get
what will you get? Positive or negative?
negative.
Yep. Okay, so it will become negative. Okay, so let's bring it over to the other side. And then this becomes negative. And don't forget, we still have this on the opposite side. So whenever you have a power of 2 outside a bracket, then everything will be to the power of 2. So what is 7 to the power of 2?
Uh, 7.
What's 7 to the power of 2?
49.
Yep, 7 times 7. And what is 2 to the power of 2?
4.
Yes. So what we have just found out is big R squared minus 4R squared, big R squared minus small r squared will give us 49 over 4. Agree?
Yeah.
Okay, so far at this stage, we have drawn some lines to form a right angle triangle. We have also made use of Pythagoras theorem. Does anyone have any questions so far? Raise your hand before I continue. Anyone have any confusion that you want to clarify before I continue? Make sure you raise your hand. Anyone? Okay, nobody, eh? So let's continue. So they want you to find the area of the shaded region. So do you agree, Kyler, that the area of the shaded region is found by taking the big semicircle minus the small semicircle? Yes or no?
Yes.
Yes. So can you tell me the formula to find the area of a circle? What is the formula to find the area of a circle? Pi what?
R square.
Pi r square, correct. What about semicircle then? Is semicircle also pi r square?
Half times pi times R times.
Half
Half
pi r
times pi.
square.
Yeah, half pi R.
Good. Half pi r square. Why did I use a big R?
Because you're finding the big semicircle and a small semicircle.
Correct. The other one is a small semicircle, right? Okay, good. Then my next question to you is, do you notice that this and this are repeated?
Yeah.
Whenever you see repeated numbers, what can we do?
Uh, cancel them out.
Cancel? No, you cannot just cancel something out. We can
Factorize.
factorize. Now, what's the meaning of factorize? Let me show you. Factorize means you take the thing that is repeated, which is the common factor. Okay, never mind. Let me show you an example, everybody. Look. 5 times 2 plus 5 times 3 plus 5 times 4. Kyler, can you just add up together and tell me the answer? Add this up
45.
together. Sorry?
45.
45, huh? 45, okay. So, how do you get 45? 10 plus 15 plus 20, right? 45, right? Now, do you notice that number 5 keep on repeating?
Yeah.
So I'm going to take the number 5, put it outside. I'm going to factorize it. That means you put it outside the bracket. And tell me what is remaining in the bracket. 2. What other numbers are
Plus
remaining?
3 plus 4.
Yes. Can you tell me what's 2 plus 3 plus 4?
9.
9. So what's the answer?
45.
Yes. Isn't it the same?
Yeah.
So students, you see, if a number keeps on repeating, then you can factorize it. You can factorize it. Okay, you'll still get the same answer and it will be easier to calculate. So we are going to factorize this. And can you tell me what's left in the bracket? What is left in the bracket?
R square minus big R square minus small R square.
Very good. And can you tell me what is the value of pi?
3.14. Oh, I mean 22 over 7.
Okay, the question say 22 over 7. And can you tell me what is the value of r square minus r square? Tell me.
9 over 4.
49 over 4, which we already found. 49 over 4. Very good. So now all you need to do is simplify. 7. Okay, let's divide by 7 here. And let's divide by 7 here. Okay, what else can we divide? Divide by 2. Divide by 2. So what's our final answer?
77 over 4.
There you go. We have found the shaded area. Well done, Kyla. Was this easy or difficult?
Medium.
Medium. You have any questions you want to ask?
Mm.
Thank you, Kyla. Well done. How about the rest of you? Does anyone have any questions you want to ask? Wow, we learned a lot of things just by doing one question, right? Come, let's revise what we have learned. First, we know about the circle. Okay? Whenever you have a line from the center to the circumference, you call it the radius. Second, we learn about tangent. If you have a line that barely touches a circle, it just touches the circle at one point, right? It does not cut through the circle, okay? It just touches it at one point. It is called a tangent. Tangent. So when you take the radius and you connect it with the tangent, you will get 90 degrees. So that's the first thing we learn, right? Then what else did we learn? Well, of course, we learned how to apply Pythagoras theorem. A squared plus b squared equals to c squared. And then we found that big R square minus small r square is equal to 49 over 4. And then we made use of the area of a circle, pi r square. But because it is a semicircle, we multiply by half. Then it becomes half pi r square, right? Then we realize that half pi keeps on repeating. So we can factorize it, put it outside the bracket. And from then on, we managed to find the area of the shaded region. Anyone have any questions? Raise your hand. All right, let's look at practice number 1. So students, here they are telling us that we have right angle triangle. So immediately, we already know that this is a right angle. Okay? Then they say that the base and height of each triangle is 5 and 12. 5 and the height is, okay, so this is the height. The height is 12. Wow, students, do you remember your Pythagorean triple? Come, I'm only going to give you 1 minute. You need to tell me what's the area of the entire figure. The total area of this entire figure. 1 minute. Use your Pythagorean triple. Your time starts now. Well done. Jingshen, Leandra, Nathaniel, Breven, Elisha, you're all so fast. You got it correct. Kyler, you got it correct. So fast, right? It's even less than 1 minute, you know. Zheyi, you got it correct as well. You solved it in less than 1 minute. Very good. Let me ask Devon. Hello, Devon. Hi, Devon. Oh, Jason, you solved it as well. Very good. Looks like Devon is not here, is it? What happened to Devon? Hello, Devon. Where are you? Reina, you solved it. Anika, you solved it. Okay, later I'll try to call Devon again. All right. So, students, well done. All of you got the correct answer. Why? Because we know the Pythagorean triple, which are the three that I told you to memorize? Let's just do a quick test. Anika, hi. Hi, Anika. Can you tell me what are the three Pythagorean triples that I told everybody to memorize? What else? 3, 4, and?
5,
Yes, what else? 6.
8, 10,
Yes, and 5?
12, 13.
Correct. Very good. So which one do you use in this question?
5, 12, 13.
Very good. Thank you, Anika. So students, everybody needs to memorize these three Pythagorean triples. And since we know 5, 12, 13, and the question is using 5 and 12, then we can say that this is 13. So what's the area of the entire figure? 13 times 13. 169. Done. It's too easy. Too easy. Moving on. Question number 2. Now, we have a quadrilateral here. And they say that AB is perpendicular to BC. So let's label the diagram. Always label your diagram, students. Makes it easier for you to solve the question. Visualize it, okay? And they say that AB is 3, BC is 4, and they say AD is 12. Okay, AD is 12, CD is 13, okay. There you go. So, students, I think it's pretty obvious. What is the length here? Everyone type in the chat, what is this length? Yes, very good. The Pythagorean triple. The Pythagorean triple that we are using is 3, 4, and 5. And guess what? You have another Pythagorean triple. 5, 12, and 13. Can you see straight away you got 5, 12, and 13? That means, since it satisfies a square plus b square equal to c square, because 5 square plus 12 square equals to 13 square, then you can conclude that this is a right angle triangle. Understand? Okay, because it satisfies Pythagoras, it is a right angle triangle. So the question is asking you to find the total area. I give you 1 minute. Find the area of the entire figure. Your time starts now. Wow, all of you got it. Good job. So now that you found out that they are right angled triangles, then you can easily find the base and the height of the triangle. So you can have half times the base. Okay, let's look at this base here. Times the height, right? Plus the other triangle. Half times, okay, let's say that this is the base, 5, times the height, 12. Now, if you add everything together, you will get the final answer, 36. It is too easy. Okay, well done. Now, question number 3. Students, the previous 2 questions are too easy, right? Now it is starting to get more challenging, okay? So now you need to try to start using your visualization skills. Can I get Breven? Hello, Breven.
Hello.
All right, so Breven, they say that the angle A is 30 degrees. So let's label it 30 degrees. Then the length of AC is 8 centimeters. The length of, then they said something about the angle C minus the angle B is 60 degrees. Find the area of the entire triangle. So firstly, Breven, are there any right angles over here?
Maybe.
Yeah,
No.
you're not sure, right? Can you assume?
No.
You cannot assume, right? Okay, can you assume that this is right angle? You
No.
no, right? Because the question did not say so. Okay, what did the question say? It says that angle C minus angle B will give you 60 degrees. That means the difference between angle B and angle C is 60 degrees. So, Riven, what do you think we can do? Is there any way that we can find any right angle?
180 minus 30 equals 150. 150 minus 60 equals 90. 90 divided by 2 is 45.
So
B
what
is-
do you
B is
45.
40. C
B is
is
45. B is 45. Very good. And C is
C is
100 and 135. Correct. Yes, Breven. Yes, you can say that because they already told you that C minus B is equal to, oh, sorry. They already told us that C minus B is 60 degrees, correct? Well
Yes.
done, well done, Breven. You have found the angle C. What else can we do?
Make another triangle. So this is 90 degrees. Make
You
someone
are correct. Make another triangle so that you have 90 degrees. So let's draw a line right here. And let's call this 90 degrees. Very good, Breven. If this is 90 degrees, what is this angle?
60.
Yes. And what is this angle then?
45.
So if this is 45 and that is also 45, can you tell me what type of triangle is this?
Right angle.
Oh no. When a triangle has two sides which are the same,
Oh, isosceles.
isosceles. Absolutely. So if the two sides are the same, the two angles are also the same. So since you already have two angles the same, you already know it's an isosceles, which means this side and this side have the same length, correct?
Yes.
Very good. Okay, so now we have found an isosceles triangle. We have created our own right-angled triangle. Next, I would like to remind you what is the 30-degree rule.
I
So
know.
tell me.
It's so the thing is from 30 degrees is half the hypotenuse.
Yes, correct. So this is the hypotenuse, which is the longest side. Then the opposite side, the side that is opposite the 30-degree angle is half of the hypotenuse. Very good. So, can you look at your right-angled triangle, the one that you created, and tell me what is the hypotenuse? How many centimeters?
8.
8 centimeters. That's the longest side. So, if you look at the side which is opposite 30 degrees, how long is that side?
4.
4. Students, look. We found the length here, 4. So, Breven, can you tell me how long is this side?
It's like
This isosceles triangle, right?
4.
4, correct. Because in an isosceles triangle, both sides are the same. Okay, so this is 4. So let's call this 4. Okay, now of course, we do not know what is this length. We do not know this length yet. So if you want, you can call it X. It's up to you. Or we can just label it. Okay, let me just label it. Hold on. Okay, let's call it point D. So let's call this point D. Okay, and we know that the length here is 4. So now you need to find the length of AD, the length of AD. So Breven, using Pythagoras theorem, can you tell me what is the formula again for Pythagoras?
A squared plus B squared equals C squared.
Yes. So can you tell me what's the value of A looking at your right angle triangle here? What is A?
A is 4.
Can I say that A is AD?
Yeah.
Yeah, actually, it doesn't matter which side, right? So you can say A is 4 as well. So 4 square plus AD square equals to?
8 squared.
Can I say that this is 8 and then this is AD?
No,
Why not?
because the hypotenuse has to be the opposite from the right angle.
Correct, students. C, right, must always be the longest side. It must always be the longest side, okay? So A and B are flexible, but you cannot change C. You cannot change C. C must always be the longest side. All right. So now that we have this, let's start working it out. What happens if I bring the number 4 over to the other side? Does it become positive or negative?
Negative.
Negative. Yep. So you have this minus this. So can you help me to calculate 8 square minus 4 square? What do we get?
64 minus 16.
Yep, which will give us 48. So how do I find the length of AD?
48 square root.
Okay, but can you square root 48?
No.
No, just in case some of you don't know, what is square root? Okay, let's say you have 4 to the power of 2. That means 4 times 4, you get 16. Now, I think I mentioned just now that square root is the opposite of square. So, if I ask you what is square root 16, guess what? The answer is 4. Why? Because square root is the opposite of square. 4 square equals to 16. Then if you take 16, you square root it, you go backwards, you will get the number 4. Okay, another example. 3 squared equals to 9. 3 times 3 is 9. Square root 9 equals to 3. So, Briven, you cannot square root 48, right? So
Yeah.
what should I do if you cannot square root 48? I mean, if it is 49, can you square root it? What do you get?
7.
Yes, because 7 times 7 is 49. So square root 49 is 7. But 48, you can't do it. So what should I do now?
4 root 3.
Very good. You split it up. Okay, 48 equal to 3 times 16. Okay, can you square root the number 3? No. Okay, number 3 cannot square root, but can you square root 16?
Yes.
Yes, and what do you get?
4 root 3.
So you get 4. Square root 16 is 4. And since you cannot square root the number 3, you just leave it alone. Leave it alone and don't touch it. So then you get 4 root 3. Well done, Riven. Now we have found 4 root 3. So this length is 4 square root 3. And this length is 4. So what is the length of? What is the area of ABC? Oh, they want you to find the area, the area of ABC. So at least we found the length of AB. Okay. So Briven, come, let's do our workings. The area of ABC equals to, okay, half times the base. What is the base of the triangle?
ADB.
Correct, AB. The length of AB. What is the length of AB? 4 root 3 plus?
4.
Yes, 4 root 3 plus 4. 4 root 3 plus 4 multiplied by the height. What is the height?
4.
4, correct. So now straight away, half times 4 equals to 2. Half times 4 is 2. So now we just need to multiply this by 2. And what's the answer, Briven?
8 root 3 plus
Plus
8.
plus 8. Correct. Well done. 8 root 3 plus 8 cm square. We got it. Thank you, Briven. So, Briven, how was it? Easy or difficult? What do you think? What do you feel about this?
Medium.
Medium. What about the visualization part, where you created your own right angle triangle? Was that easy or difficult? Does it make sense?
Yeah.
Well
Easy.
done. Thank you, Briven. So students, let's revise what was done, okay? Firstly, we look at the diagram and we tell ourselves that you cannot assume it is right angle. You cannot assume, but you can draw your own line and you can create your own right angle triangle. But once you do that, you make sure you label. Label all the angles, label all the sides, and guess what? We found that there was an isosceles triangle, which is very helpful actually, right? So the side length is 4. Okay, the side length is 4. We also managed to apply the 30-degree rule. 30-degree rule. And that's how we found the length 4. 8 divided by 2 is 4, okay? And then, of course, we use the Pythagoras theorem. And we also learn about square root. When you cannot square root a number, what you can do is you can split up the number. You split the number up. Then you can square root this part. But of course, you cannot square root number 3. So you leave it alone. And finally, of course, half times base times height. You got the area. Anyone have any questions? Raise your hand. All right. Wow, look at question 4. Very interesting. They say that in the figure below, they already gave you the area of the 2 semicircles. So the area of the 2 semicircles is 2 pi. And they also told you that AD equals to DC. Guess what? Isn't this an isosceles triangle? Yeah, it's an isosceles. They also told you that ADC is 90 degrees. Okay, right angle isosceles. Find the area of the triangle ADC. Okay, so students, first, okay, let me ask Devon. Hello, Devon. Uh-oh, is he lagging out? I think just now he got disconnected a few times. Hey, Devon, hi. Oh no, I can't. I think he's lagging. Hey, Devon, are you able to hear me? Oh no, your voice is like it's lagging. Okay, never mind. Better don't stress your Wi-Fi network. Okay, you just try to listen. All right. Let me ask Elisha. Hello, Elisha.
Hi.
Okay, can you tell me how do you find the area of a circle? What's the formula for area of a circle?
Pi r square.
Very good. But what about a semicircle?
Half pi r square.
Yes, half times pi r square, okay? What about 1/4 of a circle?
1/4 pi r square.
Yeah, I'm just asking that for fun, okay? So basically, you just multiply by whatever fraction you want, okay? So half pi r square, that's absolutely correct. Now, looking at this diagram, we can see that there is okay, there's a triangle in the middle. So let's call this A. Let's call this side B, and let's call this side C. Yeah. Now, they already told you the area of the total area of both semicircles. So if I call this side A, right, then can you tell me what is the radius of this semicircle?
Half of A.
Yes, very good. Half of A, which is, can I say is A out of 2?
Yes.
Very good. And can you tell me what's the radius of this semicircle?
B out of 2.
Correct. So let's write down the formula to find the area of a circle, okay? A semicircle. Half pi radius square. Then half pi radius square. Does it make sense?
Yes.
And what did the question say? You add them together, what's the area?
2 pi cm square.
Correct. 2 pi. So, do you notice that there are some things that keep on repeating?
Yes.
So, what can I do?
Cancel.
No, factorize.
Yeah.
Okay, so when you factorize, you take out the thing that keeps on repeating and you put the rest inside a bracket. So, what are you left with? Okay, we are left with this. plus this. Okay? Now, Elisha, do you notice that there's a pi here and there's a pi there?
Yes.
What can I do?
Cancel.
Correct. We can cancel it out, okay, because there's an equal sign here. So if you do something on this side, then you better do the same thing on the other side because it's supposed to be equal. So if I divide this by pi, then I must also divide this by pi. So when you pi divided by pi is 1. Pi divided by pi is 1. So ultimately, it will be cancelled out. Correct. Now, what about half? Okay, what if I take this entire thing? How should I get rid of half?
Times 2.
Yes, if you times 2, it'll become 1, right? Half times 2 is 1. So I must also times 2 on the other side. So let's go ahead and do that. So once I times 2, then this will be gone. Okay, so this will be gone. You're only left with a over 2 squared plus b over 2 squared equals to, don't forget to times 2 here,
4.
4. Okay, good. Very good, very good. Now, whenever you see a over 2 square, right, this power, okay, what must this power do? It must apply to a, and also it must apply to the number below. So we end up with this. Okay, which means that we'll get a square over 4 plus b square over 4 equals to 4. Okay, Lisha, can you tell me, right, how do I get rid of all the number 4? What should I do on this side?
Times 4.
Yes, multiply by 4. What about the other side?
Times 4.
You must do the same thing on both sides. So let's multiply by 4 on both sides. Then I will be left with a square plus b square equal to c square, right?
Yeah.
So can you tell me what is the length of c? What is the length of c? Okay, again, Pythagoras theorem, a square plus b square equal to c square, right?
Yeah.
You already know that this is a and this is b, right?
Yeah.
So I'm asking you what's the value of c?
4.
Yeah, 4. Okay, a square plus b square equals to c square. So now you found that c is 4. Okay, so what we have here is we have this right angle isosceles triangle, which is ADC. Actually, my drawing is not so accurate. Let me make it more accurate, a little bit more accurate. Okay, something like that. Isosceles ADC. And you know that the base is 4. The question is asking you to find the area, right, Elisha?
Yeah.
Do you know how to find the area? Not yet, is it? Thank you, Elisha. Well done. Students, look. Elisha has already helped us to find the length of AC. Now it is up to you to tell me the area of the entire triangle ADC. I'm going to give you 1 minute because it's very easy. If you visualize correctly, you should be able to find it in 1 minute. Okay, your time starts now. Type your answer in the chat. Okay, so students, looks like nobody managed to find the area of this triangle. Is it Reina? Is it because you do not know what's the base and you do not know what's the height, right?
Yeah.
Yes, students, you don't know the base, you don't know the height. How are you going to find the area? Okay, Reina, I'm going to show you something, okay? This is right angle, right? Okay, so what if okay, hold on. What if I take 4 of these? What if I take 4 of these triangles, right? And I join them together. What shape do you think I'm going to get, Reina? A square, is it? A square, is it?
Yeah.
You are absolutely correct. So tell me what's the area of this triangle now?
16,
Divide by
4. Wait,
equal.
sorry.
16 divided by 4 equals.
4,
So what's the answer?
4.
Correct. Very good, Reina. Was this easy or difficult?
Easy.
Easy. Congratulations, Breven. You got it correct. Well done. Okay. I saw some of you typing 4. Breven, you typed 4. Who else, Who else typed 4? Let's see. Nathaniel, you typed 4. Very good. Leandra, you also got 4. Well done. Yes, Kyla, is that easy? Ah, very good. Yes, Breven, you raise your hand.
I did it a different way.
Oh, a different way. Tell me, what is your method?
So, C squared equals 16. And then since AD and DC are the same, they're both 8. And 8 plus 8 equals 16. But then since it's supposed to be squared, so AD equals root 8 and DC is also root 8. Root
Oh,
8 is 8, and then half of it is 4.
thank you, Breven. But Breven, do you think that whatever you did was a little bit longer?
Yeah.
Yes. Okay, but anyway, that's very good, Breven. At least you got the correct answer. But now you know a shorter way, right? Ah, very good. I'm going to explain what Breven did, by the way. Yes, Shen, you have a question?
I feel like there's also another like simpler way.
Another what?
Cause since this is an isosceles triangle,
Yes.
I basically like split it in half.
Oh, you split into half, okay?
Yeah, and then when you split like 19 and a half is 45, and we
Yeah,
know angle DAC is also 45, which
yeah.
make that an isosceles triangle.
Very good. Yes. So you're just creating a smaller isosceles triangle and you still have the same problem. You do not know the base and you do not know the height.
Wait, no,
Oh,
but like
sorry
you
to
can
know.
split. You're splitting the four and a half,
Okay.
which is 2, and then 4 times 2, and then divide by 2.
Very good, Shen. Well done. Students, Shen's method works as well. Okay, you divide into 2. Straight away, you know that this is 2. And then it's isosceles. So this is 2. So half times base times height. Yeah. Then you get 2, right? But 2 is only half. It's only half. So you need to times 2 again. Then you get 4. Very good. Now what did Breven do? Breven used Pythagoras theorem again. So this is what Breven did. This is 90 degrees. This is A, this is B, this is C, right? But we already know that A and B are the same length because it's an isosceles. So let's just call both of them A. So A squared plus B squared equal to C squared, right? So B and A are the same. So we just call it A squared. Never mind, let's just write it down. A squared plus A squared equals to, what is C? 4. So now Breven has 2A squared equals to 4. A squared equals to 2, right? So you already know that A squared equals to 2. So how do you find A? You square root 2. So A equals to square root 2. Now, so now that you know that A is square root 2, then B is also square root 2. So what's the area? Half times base times height. Uh-oh, hold on, something is wrong. Divide by 2A squared equals to 4. A squared equals to 2. A is square root 2. Hey, Breven, can I ask you? Yes, Singson. Can you tell me what went wrong?
It's your 4 squared.
I forgot the square. Thank you. A square, B square, C square. Okay, A square, B square, and C square. So square root 16 equals to 4. So half times A square, B square, C square. Sorry, this is 8. Divide by 2 is 8. So square root 8 equals to 2 root 2. Okay, so that's how Breven did it. Now, but of course, this is a little bit more complicated, but nonetheless, he's applying Pythagoras theorem, which is not wrong. It's not wrong. Okay? So, students, let's take a look at question 5. Does this remind you of another question? Does this remind you of another question, students? Does anybody know which question it reminds you of? Yes, Breven, which question does it remind you of? Which example?
5.
Thank you, Breven. Example number 5. Let's go back to example number 5. Remember this? Remember tangent? Remember radius touching a tangent will give you 90 degrees? And we created our own right angle triangle here. So let's take a look at question number 5. Let's do the same. We can draw a line here. And straight away, you know that tangent, the AB is a tangent. So you will have a 90 degrees angle. And if you draw another line here, you have another radius. So we have actually found, okay, this is the radius of the small circle. And this big R is the radius of the big circle. We have made our own right angle triangle. And the question says that AB is 14 centimeters long, which means that this length must be half of 14. Half of 14 is 7. Students, I'm going to give you 2 minutes. I think you should be able to tell me the area of the unshaded region. That means the white area. Type your answer in the chat. Your time starts now. All right. So, Reina, you agree that there's a right angled triangle, right? The yellow one. So, what is Pythagoras theorem again? A squared plus what?
B squared equals C squared.
Yes, a squared plus b squared equals to c squared. So, if I say that, okay, let's say that this is small r square. Okay, what is another side? What is b? This is a. What is b?
R squared.
This is b, is it?
Yeah,
And what is c?
R squared. I don't know.
You don't know?
I'm not sure.
Okay. Look at this right angle triangle. This is a, this is b, this is c. Can you tell me what is c? We call it the high, do you remember? Okay, can you read this word?
Hypotenuse.
And what is the meaning of hypotenuse?
It's like the longest length. in a
The
tri-
longest side, correct. Anika, try again. The longest side, you are correct, the longest side. Look at this triangle and tell me which is the longest side.
R,
Which are, big or small?
the big one.
Yes, this is the longest side. So, once again, let's try. Let's try to write down Pythagoras theorem, okay? Now, A, okay, let's say A is small r. What is B?
Small R.
I've already said that A is small r.
Oh, 7.
7, and what is C?
Big R squared.
There you go, A, B, C. So, now what happens if you take this and you bring it to the other side? Will it be positive or negative?
Negative.
Negative, very good. So I'm going to write this down. It's going to be negative. Okay, and on the opposite side, you'll be left with 7 to the power of 2, which gives you,
I got stuck here and then
what is 7 to the power of 2?
40. Oh,
Do you know what 7 to the power of 2? 7 times 7 is?
49.
So, Reina, do you understand how we got this?
Mhm.
Okay, so this is where you got stuck, is it? Don't worry, let's continue. So now, we are going to find the area of the unshaded part, which means we're going to take the big circle minus the small circle. What's the formula to find the area of a circle?
It's half pi radius squared.
Oh, you are cutting it in half? So you're
Oh.
trying to find half of the circle?
No, sorry, just pi r squared.
Yeah, so for the big circle, we have to use the big radius. For the small circle, we are using the
Small radius. So then it's
yeah.
pi and then in brackets.
Very good. Take out pi, and we are left with whatever is remaining. And do
Yeah.
you know the value of r square minus r square? What is the value of r square minus r square?
So 49 pi.
This is 49, correct. So you have 49 multiplied by pi.
So 49 times 20. Oh, so 154.
Okay. Yes, 154. Very good. Divide by 7, divide by 7. 7 times 22 is 154. Very good, Reina. Well done. Was this easy or difficult? Was this easy or difficult?
Easy.
Do you have anything that you want to clarify? No. Okay, what about the rest of you? Isn't this very similar to example 5? Hey, most of you got it correct. Very good, students. Anyone have any questions? All right, now let's take a look at question number 6. This is a tricky one. Okay, why do I say this is tricky? Because they tell you, okay, let's say they gave you some information. This is 60 degrees. They said that, what else? B equals to D equals to 90. Okay, so they told you that these are 90 right angles. Then you have BC is 4 centimeters. CD is 6. What is the length of AB? I know, a lot of you would have the urge to do this. Ta-da! This is what you want to do, right? Unfortunately, students, this is 4. This is 6. They are not the same. If they are not the same, that means you don't know how the 60 degree is being cut. It's definitely not going to be half. So you cannot say that this is 30 degrees. You can't. Okay? So that's why I say it's tricky. You can't do that. So what we must do instead is let's draw some other lines. Okay, let's create a rectangle. Okay. Yeah, I think this looks a little bit better. So students, if you create a rectangle, right, what will happen? Do you notice that this is going to be 30 degrees? And what else do you notice? If this is 30, 90, then this must be 60, then this must be 30. So students, we're going to make use of the 30-degree rule. Remember the 30-degree rule. If you have 30 degrees in a right angle triangle, then this is the hypotenuse, right? The opposite side is half of the hypotenuse, meaning if I were to call this side x, then the hypotenuse is 2 times of x. Okay, because x is half of the hypotenuse. If I were to call this y, then this side must be 2y, because that y is half of the hypotenuse. And since we know that this is a rectangle, then this length and this length must be the same. So this is 2y. Okay, and if this is 4, then this length is also 4. Wow, you see, students, depending on how you decide to draw your lines, a lot of things can be different. If you simply drew a line to cut it like that, you are not going to be able to solve anything. Okay, you're not going to be able to do anything. So looking at the very first triangle that we have, okay, let's look at this yellow triangle, right angled triangle. I'm going to use Pythagoras theorem. A squared plus B squared equals to C squared. So we're going to have A squared plus 4 times 4, Now, be careful of this. 2 to the power of 2 is 4. Don't forget that x must also be to the power of 2. So you have 4x to the power of 2. Then, of course, we can actually just bring this to the other side. It will become negative. 4x squared minus x squared, we are left with 3x squared. Okay, 3x squared is 16. X squared equals to 16 over 3. And therefore, x equals to square root 16 over 3. 16 can be square rooted. The square root of 16 is 4. Unfortunately, number 3 cannot be square rooted. It cannot be square rooted. Leave it alone. If you cannot square root it, leave it alone. Okay? Now, so far, does anyone have any questions before I continue? Now, I'm going to look at the green triangle. Again, Pythagoras theorem. A squared plus b squared equals to c squared. A squared plus 36 equals to 4y squared. So bring this over to the other side, it becomes negative, okay? So 4y minus 3y, 4y minus y is 3y. Okay, divide by 3, you get 12. And finally, you square root 12. Now, of course, you cannot square root 12. You must split it up. Now you can square root 4. Square root 4 equal to 2, but unfortunately, you cannot square root 3. Leave it alone. Don't touch it. Leave it alone. We have found x and y. So, what is the length of AB? The question is asking what is the length of AB? 2x plus y. So let's find AB equals to 2x plus y, which is 2 times x plus y. So, students, when you multiply by 2, you get 8 over square root 3. Now, how do we do this? Does anyone know how to simplify this and add this together? Raise your hand. Does anyone know? Briven, how? What can I do?
Take away the root 3 because they both have root 3.
You can't just do that. I mean, if this is a multiplication sign, straight away I'll do this. But I'm sorry, this is a addition sign. So I can't
Okay.
do that. Yeah, I can't do that, right? Hey, sorry, students, sorry. They're asking for AB, right? I actually found AD. AB is x plus 2y. Sorry. Okay, x plus 2y. Let's do that again. X plus 2y. So I know that this is x plus 2y. 2 times y is 4. Okay, so students, how do I simplify this though? Does anyone know? What should I do? Zheyu. I think Zheyu said correct, Zheyu. Very good. So what Zheyu said is multiply by root 3. Now, Zheyu, you are a little bit correct. He said multiply by root 3. Actually, you cannot do that. Okay, now let me ask Leandra. Hey, Leandra.
Yeah,
Leandra, if I take 4 root 3 times 1, what do I get?
it's the same thing.
Anything multiplied by 1 gives you the same thing, right?
Yeah.
So can you tell
Okay.
me
So as the 4 over root 3 first.
what is square root 3 divided by square root 3?
1.
So will it do me any harm? Will it do me any harm and will it change the question if I multiply by this?
No, so then the root 3 and 4 over root 3 could be be 3, right?
Are you going to cancel it out like that? Okay, we are not going to do that. We want them to have the same denominator. Okay, so what am I going to do? I'm going to multiply root 3 by root 3. What is root 3 times root 3?
1. Oh no, 3.
Yeah, root 3 times root 3 is just 3. Then you multiply by 4. What will you get?
12.
There you go. So the final answer is?
16 over root 3.
There you go. Well done. Thank you, Leandra. Was this easy or difficult?
Do we have to like rationalize it for like the end or not?
You can leave your answer like that. Okay?
Okay.
Thank you, Leandra. Well done. Anyone have any questions? Raise your hand. So remember, when you multiply anything by 1, you're just going to get the same thing. So it's totally fine to multiply by root 3 divided by root 3. So at least you managed to get the same denominator. Okay? This was a complicated one, right, students? Don't worry. Let's try the next one. Question 7. Now, take note. Whenever you fold a piece of paper, you will create the folded part is exactly the same as the part that was left behind. Yeah, don't you see that it is exactly the same? And one more thing you need to know, since you're folding it into half, this triangle, the folded triangle, is totally the same as the other half of the piece of paper. Okay, so these two triangles are exactly the same as well. That means this triangle, and this triangle, they are all the same. They are all the same. So the question is asking you to find the area of the overlap region. Now, if I were to call this X, right? And I know that this is 16. So then I will call this length 16 minus X. 16 minus X. Why am I doing that? Because I want to make use of this right angle triangle. Can you see, students? There's a right angle triangle here. So, by Pythagoras theorem, wait. 16 minus X. Oh, sorry. That doesn't make sense. That's not helpful. Okay, why not we make use... Okay, if this is... Okay, let me redo it. If this is X, then this side is also X, because these two triangles are exactly the same as each other. So if this side is 8, then this side is also 8. And then finally, I can say that this is 16 minus X. So if you look at this triangle here, then we can make use of Pythagoras theorem. A squared plus B squared equals to C squared. Now, students, whenever you see a square, it means that you must multiply twice. Okay, so we take turns to multiply. Let's write it down first. X squared plus 64 equals to, okay, 16 times 16, which is 256. Take turns to multiply. 16 times minus x, minus 16x. X times 6, minus x times 16 is minus 16x. Negative x times negative x is positive x squared. Now, immediately you can see x squared here. Cancel them out. We can remove them from both sides. Then, let's add this together. Okay, this is minus 32x. But if you bring them over to the other side, it will become positive. So let's bring this, let's bring this to the other side. It will become negative. So in the end, we have 32x equal to 256 minus 64. Okay? So 256 minus 64 will give us 192. And so we can say x equals to 192 divided by 32, which is 6. Students, we have just found x. Any questions so far? We are using Pythagoras to find x. So, what is the question asking? Find the area of the overlapping part. That means find the shaded part, right? Since you know the area of, since you know the value of x equals to 6, meaning that the length here must be 10. So students, what's the area of the shaded triangle? Type your answer in the chat now. I give you 30 seconds. What's the area of this shaded triangle? The shaded triangle. You already know that the base is 10. So type the area now. Tell me the area now. What is the area? Very good, Zeyu. Well done. Jing Shen. Anika, you got it. Well done, Devon. Briven, you got it. Tyler, you got it. Actually, it's quite straightforward, right? Okay, so students, look. This is 10, which is the base. What is the height? The height of a triangle must always be 90 degrees to the base. I don't care whether the triangle is upside down. Even though it's upside down, if the base is 10, then the height of the triangle must be 90 degrees to the base. So the height is 8. Can you see the height 8? So we are going to find the area, half times the base times the height. And we get the answer, 40. Well done. Anyone have any questions about this? Okay, let's take a look at question 8. Oh, this is another one that is not so straightforward, okay? Don't worry. Let's read the question first. They say that ACB is 90 degrees. 90 degrees. D and E are the midpoints. D and E are the midpoints, meaning that this length is the same as this length. This length is the same as this length because D and E are right in the middle, okay? So, BE is 2 square root 10. The length of BE is 2 square root 10. Okay, let's highlight that. And the length of AD is 5. So now they're asking you to find the length of AB over here. What is this length? Don't worry, students. Come, let's label the diagram first. What if we call the entire side here X? So if that's the case, then this must be X over 2, this must be X over 2. What if we say that this length here is Y? Then this is Y over 2, and this is Y over 2. So since it is a right-angled triangle, can we just focus on the blue triangle first? Okay, so if you look at the blue triangle, we are going to apply Pythagoras theorem. A square plus B square equals to AD square, which is C square, right? The question told us that AD is equal to 5. So we have to input the number 5. Anyone have any questions about this so far? We are just following Pythagoras theorem, okay? Now, let's take a look. So let's simplify this even more. Y square over 2 square. So that will be y square over 4 plus x square equals to 25. Okay, for now, let's leave it like that. Now, let's look at the pink triangle. Again, we are going to use Pythagoras theorem. We have a square plus b square equal to EB, right? EB square. So what is EB? There you go. 2 square root 10. So we're going to write down 2 square root 10 squared. Students, everybody, come. Help me to calculate this. Can you tell me what is 2 square root 10 squared? What is the answer, students? Type in the chat now. Everyone type in the chat now. Very good, Leandra. Zeyu, are you sure it's 20? Try again, Zeyu. Devon, very good. Well done, Kyler. Yes, Breven. Elisha, can you check your answer? You're a little bit close. Reina, try again. Jing Shen, correct. Okay, so students, let me tell you how to logify this. So basically, right, what you're doing is 2 to the power of 2 and also square root 10 to the power of 2. Remember, I told you that square root is the opposite of square. Okay, so 2 to the power of 2 is 4. Square root is the opposite of square. That means they cancel each other out. Ta-da! Okay, that's how you do it. The answer is 40. So let's write it down. X squared over 4 plus y squared equals to 40. Done. Let's call this equation 1, call this equation 2, and we take equation 1 plus equation 2. What will happen if you add them together? So I'm going to add this together, this plus this. So what will happen? X squared over 4 plus x squared. So everybody, it's like 1x squared plus 1/4 x squared. What will you get? You get 5 over 4, right? So we'll end up with 5 over 4x squared plus 5 over 4y squared equals to 40 plus 25. Now, let's get rid of all the number 4. Let's get rid of them. How do you get rid of them? Multiply everything by 4. Then you can get rid of the fractions, right, students? So, but what else you want to do? You also want to get rid of the number 5. Hey, you know what? Okay, why not we just do this? Why not we just multiply everything by 4 over 5? Then you can cancel the 4 and you can also get rid of the 5. Correct or not, students? Okay? So let's multiply everything by 4 over 5. That makes it easier. So in the end, we'll end up with x squared plus y squared equal to 65 divided by 5, 13. 13 times 4 is 52. X squared plus y squared equals to 52. So students, look. We found that x squared plus y squared is 52, right? So let's use Pythagoras theorem. A squared plus b squared equal to, look at this length here, c squared. And you already know that this is 52. So what is the length of AB? Square root 52. But of course, you know 52 cannot be square rooted. Split it up. You can square root the number 4. Square root 4 is 2. 13 cannot square root. Leave it alone. And you have found the answer. Wow, not bad. Okay, this question, okay. I will say that this question is a little bit tricky, but it's a little bit tedious. So you need to look at different right angle triangle. Remember, we look at the blue triangle, and then we look at the pink triangle. So that's what we have to do. Okay, anyone have any questions about this? Raise your hand. No questions? All right. Well done, everyone. So we have completed our worksheet. Please take some time, make use of whatever you have learned today to solve the bonus question. Okay, what did we learn today? We learned a squared plus b squared equals c squared. We learned the 30-degree rule. That means this is half of the hypotenuse. The 30-degree rule. We learn area of circle. We learn how to draw lines and divide the shape. We learn how to visualize. So students, I hope that you can make use of all the things that you have learned and try to solve the bonus question. After you do it, take a picture, ask your parents to send it back to me. Then I will help you to check whether you got it correct. Okay? All right, students. Well done today. Please download the worksheet, download the solutions from the portal, and the lesson is also being recorded. So you can watch the lesson recording and do your revision. hopefully some of you can solve the bonus question. I'm looking forward to seeing your answers. All right. Well done, students. Please do your revision. I'll see you next week. Bye, everybody. Bye, Anika, Devon, Elisha, Jason, Jingsen. Bye, Kyler, Leandra, Nathaniel, Zeyu. Bye-bye.